CloudDB, shaping your new normal.
Good morning, good afternoon, good evening, everyone, depending where you are around the world. Welcome to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, CI/CD for Apex and Oracle Database Developers by Brian Spendolini. Please feel free to write questions at any time during the session by using the chat tab of the live webinar that is in the right lower side of your screen. And the speaker will be answer all your questions by the end of the session. If there is any issues during the presentation, please feel free to contact me also at any time by using the same chat window at live webinar. Now, without any more delays, I would like to leave you with this amazing session by Brian Spendolini. Thank you so much, Brian. You can start. You are now, I can see your page on non-presentation mode.
Yeah, we'll deal with that. It's a little easier to navigate, but it's big enough. If there's an issue, we can address it. But yes, thank you for the introduction. I'm Brian Spendolini. I'm one of the product managers at Oracle for the Database Development Tools organization. We are responsible, or our product set encompasses SQL Developer, Sqlcl, Oracle REST Data Services, or ORDS as we call it, as well as a new service we have in OCI called the Database Tools Service, which is mainly about creating reusable database connections to cloud databases you have in OCI, as well as exposing those databases to gives it kind of like a SQL worksheet so that you can interact with that databases, and it works especially well with databases that are behind or in public, are using private IPs and private subnets. And lastly, our team, well, the major piece of our team, data modeler. And then lastly is what we call Database Action or SQL Developer Web. And SQL Developer Web is installed if you get an autonomous database by default. You can install it when you install Oracle REST Data Services, and that has the SQL Developer Web product as well as the REST services for creating REST services. We've added recently charts and creating dashboards, so using your data and visualizing your data and putting all those little charts on a dashboard and then giving that dashboard out for people to view. We've seen a lot of usage with that recently, and that's what the newest piece of that, as well as we've had sections for using the Oracle database as a document DB. So we have our JSON section of SQL Developer Web. And then lastly, we've added some things recently for data pump scheduling, as well as performance monitoring. So that's kind of our umbrella of products and services that we have under our group, the Database Dev Group. So what we're going to talk to you today about is using one of those tools, which is Sqlcl. And inside of Sqlcl, we have Liquidbase. We've embedded Liquidbase in there, and we've actually taken the Oracle stuff out of the freeware and then rewritten it to be more Oracle friendly. And we'll see that in action as we go forward. But mainly talking about CI/CD for Apex and Oracle developers and why traditionally it's been a difficult process, as well as how we've kind of been left out in the cold a lot of the times when we have other organizations within our companies and they are going ahead using CI/CD processes. Maybe they have a Node.js or a Java app or something, and they're able to do it a little easier. And so we'll talk about that and why that is possible. So what is continuous integration and why do we need it? So if for people who are unfamiliar, continuous integration, continuous delivery or development is a process of introducing automation into the many stages of creating your applications and developing with the database. So it allows you to have these checks and balances through your process, as well as constantly be testing those changes so that anything can be found early, any issues can be found early and often. And then it also allows a group of developers or a group of people to work on the same code line at the same time so that we get more value out of that and everyone knows what's going on and whatnot. So it's nothing new. It's been around for a very long time. But again, we've kind of seen it mainly popular with our application developer friends, not so much with the database side of the house. And why is that? So it's been traditionally hard with Application Express and the database because most of the time we need individual environments. We need environments that we need to work in. A lot of times people who develop database applications or even Apex applications, a lot of times they're working off the same database or the same Application Express instance. And we tend to step on each other when we're doing that. Somebody may be editing a page the same time someone else is editing the page and they haven't locked it or they haven't said that they're working on this within their task management system. And you'll see kind of Agile, Jira, and all that stuff kind of fits well into the CI/CD process. But maybe I'm working on a package and someone, also on my team is working on the same package and I compile it and they go to work on it and all their changes just have been killed because I compiled it with what I had on my, local to me, and they have their changes and they didn't save them and they lost the day's worth of work or whatnot. And that happens a lot if you're working in the same database. So we run into development instances can be expensive, and we have issues with licensing. So we'll talk a little bit about that today as well. Another things that we've seen is database and Apex changes, especially Apex. Apex is all metadata. It sits in the database. And the biggest thing about all that is the database is a stateful environment. There are always things going on with our production database or these line, UAT development and production database. There's always something going on. You just can't stop it and move to another version very easily. So where we see the application layer, again, Node.js, maybe they're deploying in Docker containers, maybe they're deploying in a serverless environment, maybe they're in the cloud and they're using, OCI functions, or they're using AWS Lambda, or I think in Azure it's called functions as well. And they're deploying on these platforms. These platforms are stateless and they can use what we call AB or blue-green deployment, or AB deployment, blue-green deployment, lots of names for it, where they have their new environment that they've just deployed to sitting there. And then they have their old environment that's still running. And whether they change the DNS or they change it in the load balance or the reverse proxy or somewhere up on that networking layer, they're able to change what's going on and move to that new drop of the code that's running now, and then keep that old one along because these are stateless environments. And then that new one takes over and it does what it needs to do. And if there is an issue, they can easily switch back. We don't have these luxuries with the database. So how do we work with those and how do we work around those so that we know we can use these processes for CI/CD, and then if there is an issue, how to fix it? The other thing is traditionally database change tracking, Apex change tracking has been kind of a burden and we don't do it very well. So how do we have that? What tools are available to do this? Let's move on and say, well, why should I even consider doing this? What am I going to get out of this? What is the big plus for me? What am I going to find out of this? Well, moving to this allows you to standardize not only on the way you're doing things, but it allows you to standardize on processes. Everyone's following the same process. So you can eliminate these one-offs or these things that these rogue developers or rogue databases or rogue development efforts because you've standardized the process. And while standardizing the process, you've also made it repeatable. You're constantly repeating this process. People understand it and they know what's going on. So you can kind of have this very familiar pattern pushed out to developers that they know when the next sprint or the next development cycle comes along, they're able to just jump right in and say, okay, I know what's going on. I'm familiar with this. Let's do this and let's go with this. The other thing is accountability. We see a lot of these news articles where, someone has interrupted the code supply chain. They've injected something in that code supply chain, and now that piece of malicious code is now being deployed worldwide as part of a patch or as part of an update to a service or a product that you have. So using this CI/CD process and using a repository, you get the accountability. You know exactly what that developer has done and what they want to merge in your main line of code. You can see exactly, because and we'll talk about the push events and the pulling events of the code repository. But when they say, hey, I want to take the code that I developed and I want to put it into our main line of code, okay, let's have a code review. Let's see exactly what has changed, what you're trying to do, and we'll approve it or we'll not approve it. So you can see if they've added a script that says, make me a user that has a DBA rights or has all the rights possible, and here's the password so I can backdoor the system and get what I want. Or someone has put in there, delete database commands. You're able to catch that with the accountability, and that kind of goes to security. You're able to figure out what's going on. The other thing is finding issues faster, writing better code, having quality releases, having more frequent releases, and then getting that confidence from the stakeholders that these releases that are going into production are stable, they are of good quality, and you just get that better trust. So having the ability to constantly test your code as you move along the process of development. The developer is able to test your code as soon as a change is made. You're able to test the code as soon as the code is merged into the main line. You're able to test your code very easily in a dev environment, in a UAT environment. So you're able to test your code at all these steps of that process, so that if there is an issue, you stop it, you fix it, you resubmit that code, it gets tests again, and then you're able to see if you have clean or not. And then when you start merging all the pieces together, you always test those merge points, you see what's going on, so you always know what's going on with the code so you can catch those bugs. And we'll talk about the cost management or what's going on with that in a second and how we can do that. So comes down to what are the tools that we can do this. So the first tool that we have, and we talked about initially, when we talked about the products that our organization deals with, is Sqlcl. And it's just basically our modern command line SQL command interface. It's Java-based, it's very small, it's about 38 megs big to download, and you just run it and you're able to connect to any database very easily. No Oracle Home to install, no TNS names file to install. You can connect via JDBC. You can connect to autonomous database. You can connect to a regular database. You can connect to using those database connections, using that service that I talked about earlier that we deployed in OCI. It's very, very easy to do. You can also, since there is no license to get and use this utility, it runs batch scripts extremely well. So what you'll see is when we look at these pipelines later on and how we can implement CI/CD within here, you'll see that one of the ways we go and we can run this is we go and we just get Sqlcl from either, if you're inside of OCI, you can install it via yum because it's in our yum repository, or you can do a wget or a curl command, and just go and get it and then unzip it and run your stuff directly from there. So it's a great utility. It's not, like I said, it's 38 megs. It's not, 4 gigabytes big like a traditional Oracle client is. And yes, you have the instant client, but there's a lot of stuff that comes with that. This is a very easy modern way to do it. It also comes with the Oci Cloud Shell by default. So if you're using OCI and you open up a Cloud Shell session, Sqlcl is installed there by default. So you can immediately start using your database connections with that. And then what we've done, as I said before, we've taken Liquidbase. Liquidbase is a change management product. There's a few of them out there. There's Liquidbase. There's, I can see the Flyway. There's a couple other ones that do change management, but we've taken Liquidbase, we've embedded it inside of Sqlcl, and then we've made some changes to it. So we are reconciling dependencies. So if you have a trigger and a table in the same change management process, we'll recognize that and we'll create or update the table first, and then we'll compile the trigger. So we're able to see dependencies and we're able to run things in order so you don't have invalidated objects after you're done writing your code, and util RTP has to be part of your install process or your code deployment process. You don't want that. So we're able to deal with those dependencies right within the product. And then this all fits together to have that single command line using Sqlcl and then do all of your change management at the same time with that. So Sqlcl is very easy to use, and what we've done, as I said, we've embedded liquid base in there. So the first two things are the things you're mainly going to be using are LB gen object and LB gen schema. So LB gen object we're going to use for individual pieces of code, but usually you'll want to use LB gen schema. We'll talk about that in a second. But you can also, with LB gen object, we're able to pull out ORDS modules. So if you've created a REST module within ORDS and you want to deploy that into a production environment, you're able to run and pull that code directly out with liquid base gen object, get that ORDS module, and then deploy it as part of your change management process. And you're also able to take Apex applications and grab them and export them and deploy them as part of the process as well. Now, yes, you can, within Sqlcl, you can actually do an Apex export and then the app name. You can do that, or you can use liquid base to do this. As long as your script knows it, you're able to run this later on and deploy those in there. So gen schema is the one that's more interesting, because when we see people do the CI/CD process, or we see the traditional development lifecycle of a database developer, they'll be working in their instance or the shared instance or whatever they're working in, and maybe they get distracted. The phone rings, someone's at the door, or UPS or FedEx, or they have to take their dog out for a walk or whatnot. And they've been working on a bunch of objects, and now it's time to commit or save those objects. And maybe it's traditional where they just save those objects, they put them in a zip file, and they email them to their dev manager. Well, maybe in that process of being distracted, they forgot a change. So if they're not using a CI/CD process and they ship those changes off and they're like, okay, their change is great, and you go and deploy those changes, you're going to have an issue because maybe you forgot a column to write that modify a table column script, and you have a report, or you have a view, or you have something that utilizes that, maybe a PL/SQL package, and that column's not there, then nothing's going to compile, and you're going to get all sorts of errors, and you're going to have a bad release. So what gen schema does is it captures all the changes within a single schema, and it exports them for you, and it puts them into the folders, and we'll see how it does that in a second. But that's probably the best way to do it. So then you're not really worried about missing a change or missing a trigger or missing an index. It's going to see everything and pull it all down for you. And then when you do that, when you're using a code repository and you want to merge those changes with the main line of code, it's going to say, oh, even though the entire schema is there and you pull that entire schema, within that merge event, it's going to say, oh, I see that this table has changed and you've added a trigger and you've added a index, but everything else is the same. So I'm only going to merge these objects in. So it's very easy to do, and it's able to reconcile those changes. So it's part of the process. And then here's kind of a quick rundown of all the objects that we support with our version of liquid base that's in Sqlcl. So there's a lot more types that we have here than you would find in off-the-shelf liquid base or the open source liquid base. So the next set of commands we have with liquid base are going to be, updating the SQL and rolling back. So LB update is what you're going to do to install these objects as we go from environment to environment. So LB update -changelog and then the controller.xml or the particular object.xml that was pushed out. And you'll see these files and what they mean in a second. It'll make a little bit more sense later on. You can also run liquid base update SQL, and what it's going to do is it's not actually going to apply the code in your environment, but it's going to create the SQL that it would have used to apply those changes to your environment. So you can go and you can capture that, and then depending on your process for deployment, if you're just going to run the regular SQL, you can go and run all these scripts, or you can just see what's happening, eyeball it, make sure that we're good, and then you can actually apply it later on. So you have a couple choices with that. And then lastly, we have rollback. So you can roll back all the changes within and apply that were part of that controller.xml. Now, we'll talk about rollback or roll forward a little later, but just know that liquid base does have that option to roll back if needed. Okay. Or you can do rollback SQL, which is going to show you the SQL it would have done to rollback. Another one is LB Diff, and this is a good one because this one allows you to see the diff between two environments. So you'll be in one environment, you give it the URL of another environment, and the user to go in there and look at it, and you're able to see the difference. It's going to spit out a report and say, okay, between these two environments, this table is different, this trigger is different, this procedure is different. So it compares everything and it shows you what's going on. And that's very helpful if you're trying to look between two dev environments, or you're saying, okay, here's production and here is development, what's changed, and this is what I'm expecting to see as I go forward. So that's a really nice option there. And then lastly is LB DB and it's going to create the Java doc-like documentation, which is great because you could include these within your releases. So you can create this, you can have it do the Java doc for everything within a particular release. And then that is part of your release in your code repository. You'll have it, you'll put it in a folder, you'll say, okay, this is what's these are my release docs for version X.1 or X.X. And here it is. So if anyone needs to see what changed or what's going on, you're able to look at these Java docs and see exactly what's happening. It's going to give you the definitions for your tables and your procedures and everything that you would normally find within a change log. So that's very, very helpful that we have the automatic creation of the doc when you're creating this environment or this process. As I said before, liquid-based and orgs, we can just generate the object, generate the module. So if you created a REST module that exposes a piece of business logic or, some batch load APIs, or you've used auto REST enable and you auto REST enable the table, you're able to generate those, pull them down and have them in your CI/CD process. And again, it's very easy, export the module and then install it. It's very, very simple to do that. Same thing with Apex. Application Express, you're able to do this as well. One of the important things that we have with Apex is the important flags, or this skipping the export date and export the original IDs. Because if you don't do that, when you go to merge your code, it's going to see those as changes within the individual files or the file as a whole. And it's going to say, oh, well, there's all these changes, when in reality, there's not all those changes. There's only a certain amount of changes. So by getting rid of the export date and keeping the original IDs for everything, you're able to see exactly what was changed. Oh, this page region was changed. Oh, this report was added to this page. Oh, this shared component was added or changed. You're able to see much more careful. So these are things to remember as you go forward to that and look at that. And again, it's very easy. You can run the update and install the entire application, or you can do it and install all the files or an individual file. So there's a lot of power within there for your change management. So lastly, before we get into some of the change tables, you can actually do table data. So you can do LB data, object, and then the table name, and do multiple tables if you want. And then you could run the update command and push that data back in. So this is really great for moving around metadata. It's not for doing millions and millions and millions of rows. So if you have a metadata table that's part of a lookup or parts of lookups, this is a great way to do it, especially if you want to have these scripts available for developers if they're creating their own environments. We'll talk about individual environments later. But these are great to have these data to pre-seed or pre-fill certain tables within your environments or your CI/CD process. Now, it's going to just do straight inserts. We are working on having it do an upsert or a merge, but right now it's doing a straight insert. So if you do have metadata that is sensitive for IDs and you're doing a lookup by an ID, if those IDs are auto-generated by a trigger or sequence or by the table itself, this isn't going to work all that well when you truncate and reload the data. But if you're not and you're doing a lookup based on a value, it's perfectly fine to do it this way. You truncate the table and then load the data in with all the changes in it. Again, it's not spectacular for millions and millions of rows, because then you're going to have a big giant file with millions of rows. There are better ways to do it. Data pump, for example, have that table exported, and then you could just load the data in via data pump. And actually, data pump can be scripted in multiple ways. And we actually have a web conference on the 8th of December about using Sqlcl in data pump to migrate data in your databases from on-premises into the cloud, because we've built in a whole bunch of data pump stuff into Sqlcl. So it's making it really, really easy to use. So again, if you have those large tables, then data pump's probably a better way to do it, and it shouldn't be part of your CI/CD process, but it could be part of your development environment process. So all this stuff, as you generate it and you push it and you run it, is all kept in these tables. So there's a view called the database changelog _ details view, which has all the changes that are in it. And then we have, and that's basically made up of the changelog and the changelog actions table. So you look at these views, you look at these tables, and it's going to basically say, oh, when you ran this, here's the date you did it, here's who ran it, and this is the actual SQL that we ran to do this. Now, in this red box, what we have here was an example where, we created a table. We created some tables. And then what we did later is we made some changes. We altered the table, we added a column, and then we ran it again. We ran those updates in Liquidbase in that database again. Now, if you do that and you add a column, I know other change management and other pipelines do this. What they'll do is they'll copy or they'll rename the table. They'll recreate the table with a new column, and then they'll load all the data back in because the tool's not smart enough to realize, oh, well, you're just adding a column. Liquidbase, and what we did with Sqlcl and Liquidbase, it says, oh, I see the tables there, and I see that there's a new column. Well, I'm just going to do an alter table add column. And that's exactly what we did here is we've added a new column to this table. And instead of deleting the table, reloading it, or moving it, or any of that funny business, we just add the column. Very easy to do. And then again, you can look at any of the code that it's actually running within there, and it shows you the actual file name of that file that was run, so you can always see what's going on within your change management logs. So these are great, and these are created when you update the environments that you're going to. So you'll have these running change logs in your final environments, so you can always refer back to them. And this is also where we have the rollback stuff coming from as well. It matches it up with the files that we're using, and we're able to roll back and generate that SQL. So these are the tables that are in there. So you can always look at these tables and see what's going on and see exactly what was done and when it was done. So how do we start, or what do we need to start? So mainly you need, the best way to do this is a Git repository, GitHub, GitLab, Bitbucket, what have you, any kind of code repository, because you need the functionality of that code repository for the accountability, for the check-in, for the pushes, for the merges, for the code reviews. That's what you need. So you need to start with that. And it could be cloud-based, it could be local, it doesn't matter. You just need to have a code repository that your developers can use. Then, as we've talked about before, you need Sqlcl and Liquidbase for our change management process and development process. And then finally, we kind of need a pipeline process. So Jenkins is a popular one that you can use if you're in Azure Pipelines. I think Amazon has one. And then OCI also has one. We released it last month. It's called OCI DevOps. And we'll actually take a look at that today and how we can integrate that within our pipeline processes with the Oracle Cloud. Then any extra credit you'll add on top of that, whatever you're going to develop in, VS Code, some people like that, SQL Developer, everyone likes SQL Developer, UTPL SQL, a lot of people use that for when we have these pipelines and we run these pipelines and we're checking our code, we have UTPL SQL, and that's going to run all of our unit tests. This goes back to Application Express development. The thought line, or the main way of creating Application Express apps, is that you want as little PL SQL in the app as possible. So if you're updating a table or doing anything with a table, you have table APIs to do that. So within your processes and your forms and your stuff in Apex, you're going ahead and you're calling table APIs instead of directly going against the table. You're not putting PL SQL directly in PL SQL regions. All that logic is in the database. And that helps if you have that as well as UTPL SQL, because every time you create a page and it's hooked up to an API, you're able to add those unit tests inside of UTPL SQL to check exactly what's going on to make sure that they work. So in essence, you're mimicking what that page would do by just hitting those APIs directly with the code that you have in the UTPL SQL. So you can run all of your UTPL SQL tests, make sure they come back clean, they do what they need to do, and as you develop more and more and more, this folder obviously is going to grow, but it's going to give you the ability to check more and more and more of your APIs, so that when you're developing these applications, you're developing the business logic for your applications. Again, whether it's an Apex app or it's a Node.js or React, whatever kind of application you're using, these tests in the UTP of Sql folder are able to do the unit test, and you're able to see how they actually react in real world testing. So not only is it important that they compile and they fit in well with the code, you need to test them. So UTP of Sql is used for that. Terraform. What we're going to see today is we're going to see our pipeline using Terraform. Terraform is great for creating this disposable infrastructure, running your tests, and then instantly tearing it down, all via a single script. And then we're going to be using OCI, and you can do most of this with the OCI trial accounts. And if you want to do it for real, you'll see exactly how we can do it in some of the ways you can do it with an always free account. So let's just look at our environment and kind of what we're going to be doing with this environment and how we're going to do it. So this is kind of a sample environment that we're going to take a look at here. And what we're going to mimic today, what we're going to walk through is our developers. They're going to be using a code repository. We're going to use GitHub. And what's going to happen here is GitHub is going to be hooked up into OCI DevOps. And what's here is this, actually the arrow should probably go this way. Whenever something happens in the code repository, OCI DevOps is able to see that. So whether it's a push event or a merge request or a merge of the code, we're able to hit a trigger. And that trigger is going to launch a pipeline within our DevOps environment. And it's going to use Sqlcl and Git and Terraform to do what we need to do. And that's going to spawn resources. So it can spawn an autonomous database. It could create a pluggable database as a copy. It could bring up compute resources or load balancer or pull from the object store or create network resources. All that can be done with scripting in Terraform. So you can create these mini environments to test your code, especially if you're going in with a larger development cycle. If you're part of the development cycle that other teams are part of, say the Node.js and they're deploying the Kubernetes clusters on Docker, or these compute instances have or load balancers or on the compute instances or app servers when you're deploying stuff to there, or Node.js or what have you, they can all be part of these test processes. So you have this giant test process that launches and it checks all this code after it instantly creates all this infrastructure on the fly and then tears it down, which is great because it's very easy to control your costs this way, because the environment is only using resources for the time it needs it, and then it's destroying them and you're no longer paying for those resources, which kind of goes into individual development environments. So as we go through this, one of the most important things we need here are individual development environments for our database and Apex developers. So this is where a lot of people see it getting very expensive, but using the power of some of the features we have in the Oracle database, or using the power of the autonomous database or some of our cloud features, you're actually able to do this in a very cost-effective manner. And you have to look at this as a bigger picture, because let's say I use some cloud resources and that whole process of testing the code costs me $10, and I do it 7 times a week, or per developer, and I have 10 developers, so maybe that comes out to $700 or $500 or whatever it's going to come out to. What's the cost of that compared to if I don't test my code, or I have no ability to run these processes to see how it's going to work with a real environment that mimics production, and it goes to production and we have a crippling error that takes the system down, or a crippling bug that takes the system down, and we have to be offline for a certain amount of time while we scramble and figure out what's going on, where the issue is it in the networking, is it in the database, is there a database issue, and all that time it's going to take. What's that going to cost you than just using some of your funds or some of your budget for making sure you have adequate and complete testing of the entire stack or the entire architecture that you're going to be using. So that's an important thing to keep in mind. On the database side of the house, we can create these individual environments in a couple ways here. So starting with the cloud environment, with the autonomous database. So the autonomous database allows us to create metadata clones of, let's say, production or UAT or a development environment, and then we're able to use those metadata clones to try our code and run those processes. Let's say the database, our production or a UAT or whatever databases, they're huge. Let's say they're 2 terabytes big. Well, if I'm just going to test my code and use some unit testing on those code to make sure the APIs work and the code compiles and everything's complete, I don't need that 5 terabyte database. I just need the metadata objects. So we do have that option with the autonomous database to clone a metadata only copy of that database for us to use, and then run our code checks or run our change management, see what the results are, and then instantly delete it. And the autonomous database, I believe you're charged per second. So if you're up for 60, 90 seconds to run this and test this, it may cost only a couple dollars to do. And what's the value of that compared to, again, hitting a bug in production? Using our other environments, if you have a VMDB or if you have XSCS, you can use some of the cloning environments in there. You can just issue straight SQL as part of your environment and create a metadata only clone, or you can use the XSCS environment and create a sparse clone, which is a write-on copy clone. They come up very, very quickly, and they're very easy to use, and they're very easy to delete, and they take up very little space. So again, if you have this large database, Exadata, it's a 10 terabyte database. It's a huge database. I can create this sparse clone copy, and it takes up very, very little. It's not going to be it's not going to be a full copy because we're using the sparse disk. So maybe it takes up 10, 20 megs, maybe a gigabyte of space for all the processes and some of the stuff it needs. It's not going to be a complete copy, nor is it going to use that time to copy a 10 terabyte database, which is going to take a long time to do. So that's a very efficient way of creating these copies and doing them. And then that kind of plays into multi-tenancy. If you are licensed for multi-tenancy, or if you're on a 19C or 21C database, you can create 3 pluggable databases for free without needing the multi-tenant license. So we have DB APIs. If you install ORDS into your environment, Oracle REST Data Services, it comes with all these APIs, and you're able to use those for pluggable database lifecycle management. And you're able to hit these REST APIs via your pipeline and clone the database, or you can use the REST-enabled SQL service with ORDS and just pass in SQL that says, create pluggable database as clone XYZ, and you're able to do those clones, connect to that database, test, and be done. If we're using older databases, maybe you're stuck on 11G and you're planning your migration because 11G support is pretty much done, we can use guaranteed restore points or flashback database to have these environments that are pretty much very similar that you can use. RMAN duplicates, data pump, or if you're into Docker, you can use Docker's virtual machines. You can also create clones with ACFS as well as GDB clone to create database clones as well. But the most important things in this process is to make sure that you're giving your developers those individual environments so we're not stepping on people's toes. We're not overwriting code. We're not compiling over people's code. Everyone gets their own environment to develop and work in. And again, these are some low-cost options to look at when doing this. Now let's look at a typical flow here. So if we look at the high-level flow of a CI/CD process of what you're going to do, you're going to start your sprint or you're going to start your development process. You're going to hand out the tickets. Everyone gets the tickets, or however you're going to do it, the JIRAs, whatever your tasks are supposed to be done. The developers will go, they'll work on it. They're checking their code after they're done. You're going to do a code review with your development group and maybe the stakeholders. You're going to approve that code. It's going to merge in the main. The sprint ends, you create that version, and then you release that version into all your environments for doing your testing. So this is just a typical development flow. So how do we fit the CI/CD process into this? Well, we start with a baseline of our application and maybe our database schemas and our application. Here's our baseline. Here's version 0. We're starting CI/CD process. Okay, we commit that code to the repository, and then in our GitHub repository, we say, okay, this is version 0. We take version 0. That gets zipped up, put away, gets tarred up, put away. And we can refer back to it. We can always grab it and install version 0, but we create a version, again, using the power of the code repository. Development Sqlcl starts. All the developers pull the main code down with Git, and then they create a branch. Developer A branch for ticket XYZ, developer B branch for sprint 1, 2, 3, whatever they want to call their branch. They'll create their branches and they'll start working in their individual development environments. Once they've done, they're going to basically push their code, to the branch, and then they're going to ask that branch to be pulled into main. Now, certain repositories call it merge, some would call it pull requests. All you're doing is, in essence, merging the code into your main. You're going to basically merge that code in the main. You're going to test it before it gets in there. Once it is merged, you're going to test it. And then if everything comes back clean, that's going to be your new main. So developers can refresh their branches with the new code that just got merged and continue to test and develop. And then when you're done, you have your development cycle, or your development code that's ready to go because it's been tested and all the developers are done. You create a release in the GitHub repository, and then you're going to start your deployment and production deployment pipelines after that. So this kind of gives you a flow of what the development process would look like using CI/CD. So actually, we'll skip to an example. So this is an example pipeline process. So this is a process that would run when a push or a pull of the code would happen. So developers are going to push their code to the code repository from their local repository, and then they're going to ask for, like I said, a pull request or a merge request. And this is a type of flow that would happen. So once that happens, the push request or the pull into the repository, you can have these webhooks, and we'll see how to create a webhook for OCI tied to your GitHub repositories. And then you could look for or listen for particular events. So let's say the developer has finished developing locally, has pushed the code to their branch. Once that happens, the Git repository, the pipeline wakes up, it starts running. We grab a complete copy of that code from the branch, and Terraform or the certain scripts are going to run. We're going to create these development environments, these throwaway development environments that are a copy of, say, production or a metadata copy of development. Sqlcl is going to apply the object. Sqlcl is going to install the Apex app if you're doing it. We're going to run the UTPL SQL tests. And then the pipeline, say, is going to look for any OR errors. If there are any OR errors in there, we instantly fail the pipeline. Everyone gets notified the pipeline failed. Developer is going to get that notification as well. They're going to go, okay, what went wrong? They're going to dig into the log files. Oh, well, I missed this grant. Oh, this happens. They're going to fix the error. They're going to push their code back into the branch, and this whole process is going to start again. It's going to keep going until you have a clean pipe or a clean run, and then you're able to start looking at merging that code into the main line. Again, every time we run this and every time we find an issue is an issue that's not going to make it into production. So bringing up these temporary environments that have to be brought up, and let's say they're brought up for being deployed into 60 seconds, 90 seconds, 2 minutes, 5 minutes. If that only costs you a couple dollars, whatever cloud environment or whatever way you're doing that, either locally or in a cloud environment, the cost savings for stopping and catching these bugs from getting into your production environment is in essence invaluable. You're not going to grind your production, production to a halt. Your production issue isn't going to be taken down, or this error or this bug isn't going to take production down. And again, that spawns confidence in your development group. Your developers are more confident. Your stakeholders are more confident. Your stakeholders are happier. Your end users are happier that you're having these clean, quality releases that are getting into production without any issues. Okay, so next is deployment. So deployment is something that it all comes back to how comfortable you are with doing a deployment into production. Are you comfortable with automated production deployments, or is this where you as a development organization draw the line and say, okay, we've done these tests, we know the code is clean, I'm gonna basically log into whatever environment, I have the code as an artifact, as a zip file, I'm just gonna run it myself because then I can catch any issues. This is where, again, it comes down to personal preference. It comes down to how comfortable are you with the automation. Maybe you start automation of deployment in these environments on a less mission critical application. And then once you're comfortable with those and you've proven it works, you start moving to more and more critical applications. Or again, you just run this manual. It all depends on what you want to do. But when we start looking at running these pipelines with the automation, we can do this, either have individual pipelines for environments, or we can use tools such as, say, Spinnaker, which will look for certain triggers or environment variables that you pass it and say, oh, this is going to deploy into development. This is going to deploy into UAT, or you can have interaction with those pipeline tools where it's going to wait for you to tell where you want to go. You log in, you say, okay, this release is going to development, and then it continues on its merry way and it runs the pipeline. It all depends on how you want to do this, or you can just manually do the pipeline. You create that automation. This is development automation. This is production automation. This is UAT automation. You go to that pipe, you hit run manually, and then that pipeline runs and it grabs the code and does what it wants to do. This is a personal thing. It's dependent on, as I said, how comfortable you are, but just know that the options are there to automate a lot of these things. So whatever way you go is dependent on what you want to do. Now, when there's issues, when we do have issues in production, the trend seems to be to roll forward rather than roll back, depending on what the issue is. Again, this is something that you in your development environment are going to have to figure out and work on in the process and figure out what you want to do based upon the issue. If you roll forward in production, you fix the issue, you take that code, you backport it into your code repository, there's your fix, and then that gets in there, and now you don't have that issue. But again, it all depends on what the issue is and how comfortable and how quickly you can fix it. And then just remember that if you do roll forward, you have to take that fix and then backport it back to that release. Maybe backport it to multiple releases, or just have that fix handy as you go in. It all depends on what the release is. But again, liquid-based can roll back, but you may not want to. So just know that rolling forward or rolling back is all dependent on what's happening or what you want to do. Just know that there are ways to do it. You can even, if you want to use some of the ingrained Oracle abilities, you can take a guaranteed restore point before you release. And then if you need to do a flashback database to that guaranteed restore point, which was before that went into production, you can go ahead and do that. But again, if there's transactions coming in, you're using addition-based redefinitions, you're not shutting down, or you can't take any downtime. You just have to be cognizant of what's going on with your database. So if you do guaranteed restore points and you flash the database back, you're not losing X amount of transactions that are happening. So just know that that is something we have to be aware of when you're doing the rollback or rolling forward. All right. So now let's actually look at this in real time. And what we're going to do is we're going to mimic our development environment, or mimic a development lifecycle that we would use in the process. So what we're going to do is we're going to log into an environment, what we have. And we're going to be using Oracle Cloud for this because that's where all my stuff is. And let me just log in really quick, and then I'll share that particular page. Okay, so here we are in OCI, and what I'm going to show is we're going to jump over and look at DevOps really quick. And so this is where we're going to start or use the code repository. So over here in developer services, we have our DevOps, and we're going to go to our projects. And I already have a project pre-created, just like a good cooking show. So here we have our CI/CD demo project. And again, creating a DevOps project is very easy. You just name it, and then you select a topic or a notification method that you can use. So you can have notifications enabled with your processes. So we have this one that's already built. And in here, we have some stuff that's already created, but let me go over each of the pieces here. So one of the pieces is that I talked about is code repositories. So with OCI DevOps, you have two options. You can use the local code repository in OCI, So it's going to create a code repository that you can use within OCI. It acts just like Git. You can pull code, push code, do all that fun stuff with it, or you can mirror a repository. So say you standardized on GitHub and you want to use that repository here, you can mirror a repository. So what I've done here is I've already set up this repository here, and this is mirroring this GitHub repository right here. So this is what we have that we're going to be using. And then we see that it is mirrored here. And this is the only object we have in it. And then we have our branches, if there's any branches. So it kind of gives us, we're able to do this. And then you're able to edit the mirroring interval, or you can synchronize it now. As a bunch of things you can do with this repository. But we know that we have this repository hooked up from GitHub to OCI DevOps. So now that's the repository we're going to be working on. So back here to OCI DevOps is now what we do. Once we have that repository created, we're going to create a trigger. And a trigger is going to be an event that we're going to be listening for from our repository. So here what we have is we've already had a trigger that is looking for when a developer pushes code on their branch. And creating a trigger is very easy. You name your trigger here. You select your connection type. So we're going to say GitHub. And then what you do is you can add an action. And here are the actions that we can listen for right now. And I believe the development group is adding more. So a push, pull request created, pull request updated, pull request merged, or pull request reopened. So depending on which trigger that's firing, you can have different pipelines being used. So that brings us over to our pipelines. So what we want to do with these events is we want to do a build pipeline. So here's a build pipeline, and I have one created, but I'll show you that we can create a build pipeline pretty easily. So we go create build pipeline, and we name it. And then we say create. And what this is going to do is it's going to create our pipeline. Hey, there's our pipeline. So let's actually see how we work in this pipeline. So the pipeline canvas editor comes up, and we're able to add a stage. And in this stage, we can do a bunch of things. We can work with artifacts, we can trigger a deployment, we can wait, or we can do a manage build. And what we want to do is we want to use the manage build. And then you enter the stage name. The build agent compute is going to just be a simple 8 GB, 1 CPU compute. The base container image, right now we just have Oracle Linux. The build spec file we'll take a look at, but build_spec YAML is the file that we normally use. You select your code repository here. And again, we'll go and say we want the GitHub repository. And then here it is. I can select that GitHub repository that I want to use, that connection. And then it's going to say, hey, which repository do you want to hook up to this? So here are all my repositories I have in a big old select list that I can choose from. As soon as the screen, but what I want to do is it's not showing the select list with the screen share, that's okay. But just know that it's you can pull from any repository. We want obviously the CI/CD demo repository that we're going to be using. So I will cancel out of all this because we already have one created for us to use. And this is our test the database code. So let me just delete this repository. Yep, I'm going to delete this. And so this one, what this does is it goes and it tests our code, and then it saves the code to our artifact repository. And OCI has a built-in artifact repository that we're able to use so that we can use that artifact repository to store off our code versions and have it done. And again, you can use that as part of your deployment environment, as well as if you want to use this code in your deployment pipelines, we're able to pull those artifacts and use them in the deployment pipelines. And then always, as I said, you can always start a manual run, or you can have this trigger. So this particular pipeline is going to be triggered every time we push code. So let's actually go and we'll go to our build history here. And so this is the one, again, in case what we do as our demo doesn't work, I can actually show you a full one. And this one failed because I reset our environment. So it should have failed because there was no files for it to use. But what we're going to do is we're going to jump into Sqlcl and actually build up an environment so we can see how this whole thing works. So we're going to stop share and we're going to jump over into our environment here. Here we go. So here's our environment. So what we're going to do is we've pulled the repository down and we're sitting in that directory. So if I do an ls, you'll be able to see that there is what we have. We have some folders pre-created. But what we want to do is we want to start by logging into Sqlcl. So I have Sqlcl installed here. And so we just do Sqlcl no log and it's going to log us in. Now, depending on what environment you're going to be using, we have a autonomous database that I'm going to be using. It's an always free service. I'm going to set the wallet so the autonomous database can use a wallet to log in. I'm just going to set the wallet path. And then we're going to log in to our database here. And then we're going to connect and give it the password. All right, so now we're logged into our database. Now, one of the cool things with Sqlcl is we've added this thing called the status bar, and I'm going to turn the status bar on. And what this does is it shows us on the bottom of the screen, it shows that we're using the VI editor. It's showing that we're logged in, or the important thing is that we're logged in as the demo user, and that the connection or the database we're logged into is this database, adb21_hi. That's the database we're connected into. So you always have that information there for you ready to see. Now, what we want to do is we actually want to move into our database directory. So we're able to use OS commands with Sqlcl. So we'll cd there, and if I do pwd here, it's going to say, okay, you are in your database directory. Okay, so I'm in my database. We're going to turn some of the things off here just to make a cleaner build. We're just going to set the storage things off so it doesn't grab any of that when it's pulling the code. And we're going to create some things here. So first thing we do is we're going to create a table. So here's a create table command, and we're going to run that command. And there we go, we've created it. Now, real quick, Sqlcl has a lot of cool things. And one of the things is if I type tables, it's going to show me all the tables I have within this particular schema, which is kind of cool. It's kind of a built-in thing that we have in there. All right, so next we're going to create a procedure. It's just a procedure that alters the table. It's nothing, we're just kind of filling the environment with some objects. Okay, we've created our procedure. And then lastly, we'll create an index on our table. There we go, we've created the index. Lastly, we're going to fill the table with some rows. So I have the script right here to add those inserting into trees, our tree table. We have that. Now if I do a select from trees, we can see that there is some data in this table. Okay, so now as a developer, I've created my environment. I'm ready to use my application. I can start pulling this code, and we want to generate the entire schema. So we'll do a liquid-based gen schema, and we'll grab all of it. Now -split allows us, liquid-based will start taking things and putting them into individual folders, and the -SQL command will, alongside of the files, the XML file that liquid-based needs to use, it's going to generate the SQL files. That's really great because when you're doing change management and you're checking in these things, instead of seeing these liquid-based XML files, you can actually see the SQL files and see a lot easier which is changing between versions. So that's what we're going to do, and we're going to go and we're going to run this, and we're going to have that in there. So this is going to go, it's going to look at the schema, it's going to start looking at things and start grabbing all of our code for us. Okay, so we have that code grabbed. What I'm going to do behind the scenes here is I'm actually going to add some files to the top level directory while this is generating. I'm going to add these to the top level directory, and we'll take a look at that in a second. All right, so we've run this, and we have our code Done. So what we've done is we've pulled our code, and when we look at what we have here, we're going to be able to see that we have our code in our directories here. You can also pull the data. My data was not working earlier. Let's see if it's going to work for us today. My version of Sqlcl is a pre-release that I grabbed from our development line, so some things aren't always working as they should. It's not a production one, but that's the command that you would do to pull the table. Yeah, I got a weird version, so it's not going to do that. Otherwise, it would have pulled our data for that table. Okay, so now we have our environment pulled. So we'll do an exit. We'll leave Sqlcl, and then we'll look at our environment. So I've added a build spec for our pipeline, a db.terraform file, which basically is the Terraform to create an autonomous database we're going to use and apply this code into, and then an lb.sql, which basically runs our liquid-based changes. Now, if we go into the database directory, you'll see that we have the controller XML, which is our changelog file. We have a folder index, procedure, and table. So if we go into the table folder, you'll see that we have the liquid-based XML file. We also have the SQL file. So if I cat the SQL file, we'll see that there is our SQL that we're going to use to create this table as our change management. And again, we'll pull the create table every time, but if you have added a column and you apply this to a new environment, it's going to say, oh, I see that environment has a column that's changed. I'm going to just alter the column instead of recreating the table or doing some funny business by moving the data around. Okay, so now that I have this, we're going to use some git commands, and we're going to say git add that, and it's going to add all the files that are in my folder now. And then we're going to commit the code, commit /m, and we're going to call this version 0.0 because we're taking a baseline. This is a baseline of our application. And we're going to commit that. And you can see all the files that we've changed. Now, again, as I said with Sqlcl, we can also pull Apex files. I didn't have a chance to make an Apex file, but we can also do that. And that would be part of the process here as we push the code. So you would basically use, as I said, that Apex directory that we have there. And you would put your file in there, and then liquid-based, you can add to your liquid-based runner and say, okay, when you're done creating the object, go and install the Apex app. So now that we have this, we're going to push the code into our GitHub repository. So we just do a git push. And that's going to take the code and it's going to push it into our environment. Now, let me change our share here. And we're going to go back and we're going to share the browser here. So let's go here. Okay, so we see that we've started a pipe. So this pipe has started because we did a push event with our code. Now, granted, if I was a developer, I wouldn't be pushing the main or the master line. I'd have a branch, but just for this demo, we're doing that. If I go to my repository and take a look at my repository, we can see all the code that we just pushed up. And so we have our database, we have our folders, we have our files, we have our liquid-based SQL, and we'll take a look at that. All it is going to the database directory, and it's running the liquid-based changelog and exiting. So that's just going to update the files in the database or run the changes. And then we have our database Terraform file. This is a little bigger. This Terraform, if you're easy to, and actually we have samples of all this online for people to use. But all this is saying is that create a random password for our database, because you need that when you're creating a copy of an autonomous database. And then create the autonomous database. And this is all the code you need to create an autonomous database. That's it. You just need to name it. And again, we don't care what this database is doing. And if we actually look over in here, since this process has started, I can actually go to here and I'll open up a new tab with the autonomous database here. And we'll see that this process has started creating our autonomous database. We'll see our master or our production or whatever you want to call it in here, as well as a database that we should see that's creating called dbtf. That's what so there it is right there. It's provisioning, and then we have this as our main environment. This could be an always free database as well. You can create a copy of an always free database, but this just for the quick, I just created a regular one. So back over to here. Once it creates that environment, it grabs the wallet and it takes that wallet and puts it local to our build runner. And then all it's going to do is it's going to have Sqlcl is installed on here, and it's going to run Sqlcl, and it's going to run our script, taking in that password as the admin password of our autonomous database. Once that's done, we delete the database as part of our Terraform. We destroy it. So if I go back over here and we look at our pipe, we can take a look at, and here are the log files. And what it's doing right now is it's running the Terraform code. So we can see here, we can see all of our logs, and we can see what's going on. And so it's installing Sqlcl, it's getting it all ready. And we'll take a look at the build runner in a second. It created the database, and now it's going to run and create that database. And once that database is done creating, it takes about 60 seconds for an autonomous database to come up. It's going to install the Sqlcl file. So it's going to create a table, it's going to create the index, and it's going to create that procedure for us all in that autonomous database. It's going to show what's happened to it if there's any errors, and then it's going to go ahead and delete those resources. So this autonomous database may have been up for maybe 15 seconds, 30 seconds, and I'm only charged for the time that that database was up. I'm not charged for a day. I'm not charged for a month. I'm only charged for those seconds that database was up, which makes it huge in a cost savings because I'm only being charged for what it was costing me. So if we actually go to our build pipeline, and what I'll do is I'll cheat here, and I'll show you one that succeeded earlier, and we can go a little bit more into this, and we'll actually open this up so you can see it a little better here. So we'll let this run, and we'll get to the Sqlcl stuff as soon as I can find it here. Okay. So once this catches up, you can start seeing here. So what we did is Sqlcl was started. You see that we logged into the database, and then we started running the script. So here is the XML table to run the script for the table. Here is our procedure. And then here is our index code. So it installed all of these objects into this database. We have 0 errors. And then it leaves Sqlcl. After it's done with Sqlcl, what it's going to do is it goes ahead and it deletes our database. And you can see the delete command here. It destroys the database. It finishes. And then what we do is we save the code to our repository. So now we have the code in our repository as a clean build of this code. So it's now, again, granted, you don't need to do this as part of your build process. You don't need to save off the code, but you could. It all depends on what your pipeline you want to do. So that is a typical build pipeline that you can do. Now, if I look at the build runner, the build spec YAML file here, so we can actually see what's going on. And the first thing we do is we set up OCI CLI to work. And what we've done is we've stored some of the information we need to get OCI CLI to work on this build runner in an OCI vault. So it's encrypted in the vault, and we can decrypt it on the fly. Now, I believe one of the changes they did before this was released to production, DevOps released to production, is they made this whole step moot. They actually do it for you, or they're using the resource principles of OCI with this build runner, so you don't have to do this. You just need to give DevOps permissions to do certain things within the policies. So this thing all goes out the window. You don't even need this anymore. Then what we do is we go and we install, we add this repository here. We install Terraform. We go and we get the latest version of Sqlcl. We unzip it, and then we start running our Terraform. We apply it, and then once everything's happy, we destroy it. We zip up our code that's under database.star, and then we deliver that code to our artifact. And that's it. So this shows you what you would do with, initial baseline, and then again, shows you what is in master. Now, again, as we saw with that pipeline, what normally would happen is if this is master, this is version 0. Again, with the releases, I can take a release. This is version 0. We have the source code for version. But at any time, let's say I updated the database, I can draft a new release, and then this is all saved off. And now we increment this code. Again, the developer branch is going to have their own developer branch, and they're going to do a pull request. And when we're happy with that pull request, we will update master with that. Our versions will change. Once we're done with the sprint, we'll take a release. And what happens there is that we always have the latest copy that we run in certain pipelines. Now, again, when you trigger the events in OCI, in the DevOps here, again, they could be looking at particular developer builds as well. So they don't have to look at just master all the time. But when you do a pull request and you check the code for a pull request created, or you check the code for a pull request merge through those triggers, you want to pull from master. Sometimes, depending on how people use GitHub, they don't really touch master until a release is done. So they create a branch with the version, and then the developers take a branch of the branch for their particular versions. It all depends on how you like using GitHub. There's lots of ways to use it. Again, it's up to you to figure out how you want to use it and how you want to do it in the pipeline. I do see one question. What if I need to execute an incremental release of a version? I mean this from version 0 to version 1, including Apex app and some DB objects. Yep. So that was the same thing. You know, you'll have your branch. You'll merge that code into that branch. Now, again, how you do the releases and how you version things is mainly a process that you're going to implement within your developers and with GitHub. So creating the branches, having the developers create the branches. So there's a lot of ways to do one-offs in GitHub. There's a lot of ways to do patches. Just know that every time you create that patch and you're pulling that code, you want to pull from the correct line. You want to test with that particular patch or that particular version or point release version, and then push it all into a final release. I've seen, GitHub diagrams where there's so many branches because you're doing so many different things. Again, the more and more you use that standardized process of having all your developers in individual environments and having them stay on a particular branch and release, and you're catching these bugs, the less you're going to need to have these one-offs. Now, granted, these one-offs are going to happen. Database change version and something happened, or this changed and something happened. You need to create these one-offs. That's always going to happen. Best way to do that is create a separate branch in GitHub, work on that branch, can pull that as a pull request, and then have that going back into main. I think we have a bunch of diagrams within one of our blog posts that we did, which are giving idea of how you want to branch based upon what happens. But it all depends on how you would do it and what you want with your branches and how you want to put your pointer releases. But for this part, now that we have version 0 done, we can go, if we wanted to, actually, there's a little bit of time left. So what I can do is I can say, okay, let's stop sharing. Let's go back to our environment. So here is our environment. Let's log back into the database here. And let's go and do something with that. So we'll set our cloud config, and you can always press up and go and, there's a history with Sqlcl. So you can always do your history. We'll connect into it. We'll add that. Our password. We'll turn our storage off. Okay. And then what we can do is we can go ahead and let's add a column, say, for example. So alter table. So we've altered the table, we've added a column to that table. Now what we can do is we can do a generate schema again. So we'll just cd to the database, make sure we're in the right thing, Now we'll do liquid-based gen schema. So what this is gonna do is it's gonna go and it's gonna pull the new code with this table alter in there. And we'll take a look at that. So while this is running, we'll go back and we'll look. So if I do, where is it? Here. If I go look at my database code here and we look at our table, here's our table SQL. We've added a column. So this is the last It's spelled incorrectly too. I forgot to change that. So that's our last column. But what we're going to do is we're going to go and we're going to actually add that column here. So let's go back to Sqlcl. So our code has changed. We'll exit out here. Now what's cool is when I go back here and I do a git add. Oh, I went too far up. And then I do a git commit. And we'll do the 0.1. It's going to say, oh, I see only 2 files have changed. So when I do a git push, it's only going to push the 2 files that we changed, which are the controller XML, because now it knows about it, as well as the table code. So again, now a pipeline is running. So a pipeline, if we go, let's go back into our web browser here. And if we go to our database code here, we see that our table code is now version 1.0 because Liquidbase was smart enough to say, and Git knew that there were no changes. It says, hey, the only thing that changed here was that table code. And what we did is we added that extra column called tree picture here. That's the only thing that changed. So it's smart enough to know that this was the change. And if we go to the top level, we'll see that, you know, this is the one that has changed. And now what we could do is we could take a release of this. So we'll create a new release. We'll call it the 0.1 new column. And we can do publish the release. Oh, we need a tag. Choose a tag. The 0.1 on that tag. So there's our tag, and then publish the release. So now we have that release created for us. And so then if we go to our releases, we have version 0 we can always pull from, and then we have our version 0.1. So our initial release and then our version 0.1. Now, if we jump back over to here, we'll see that there is a build pipeline going on. There's 2 because I changed to, why is there 2? Oh, there's 2 because I can't remember why there's 2. Oh, because it's still going on. That's right, it's still going on from when we changed initially, and then there's a new one running as well. So this is going to go ahead and run and do what it needs to do. That's why. So yeah, so that's what's happening there. So again, you can dictate what happens and when this, oh, you know why? Because I did a release. We did a release that triggered, and so this is a release because it pushed it. Okay, that's why. Yep, that's why. So we have the initial table change push, and then we have the creation of the release. And we can change these triggers and how we want to do this based upon what GitHub is sending over as specific commands. And I think I made it send over everything. That's part of your webhook when you set your webhook up in here. So that's part of your external connections when you connect the two. And these are going to run, and it's going to do what it needs to do. Here's the one that we ran today with the initial build. And then, you know, we see that it was successful, and it saved the code off. And then again, here's our log files here, all the stuff that's going on in here. All right. So that brings us pretty much to our end of our demo. So there's some things we just want to wrap up with here. So how do we start, or what do you want to do? Well, the best thing to do to start with this is to go slow, incorporate small pieces, do certain things bit by bit. Start using a code repository as step 1. You know, get developers comfortable with that. Then maybe you start working with Sqlcl and Liquidbase, and then you start adding pipelines, and then you start adding more and more. But go slow. For a lot of folks, this is going to be a big change, especially traditional and database developers who haven't really done this in the past. They've pretty much shared zip files with each other. Just go slow and start very, very slow. Now, a lot of this stuff is hosted in our GitHub folder. So you can go here on GitHub, and we have a whole bunch of samples and in that folder that you can take a look at for doing these, exactly what we did here, as well as our documentation. We have Oracle Live Lab, So we have a live lab that we've done that runs you through using Sqlcl to pull changes. So that's something new we added recently for Database World last week, or 2 weeks ago, or this week. It's a multi-week event. So there is a live lab that you can take a look at that will actually run you through using Sqlcl and creating these objects very similar as we did, and then having those change logs, and you could add that GitHub part to it. Lastly, you can reach out directly to us if you want, and we have a Discord group as well if you're into that type of a thing that we talk to our developers and help them out on there. So that pretty much wraps it up for us. If there are any more questions, I can address them. If not, I think we could end here. I think we are all set, maybe. You have some people typing, it says, so we'll wait a second. The Discord group. So let me go and grab the Discord group here. So we have our Oracle Dev Discord group. And what I can do is I can set I think I could put it into the chat here. There's a link to join our Discord group. A bunch of people on it. It's just called the Oracle Devs. The PMs, the database tools PMs are on there. Multiple channels. We talk about, if people have any issues or what you want to see in the product. It's not really a support line, but it's if you do have an issue, we can kind of walk you through it. It's not supposed to obviously take priority over Oracle support. But if you were questioning or you had an issue or you're wondering, is this supposed to work this way or how do I do this? The PMs are on there. Jeff Smith is on there as our another one of our PMs in our group. Everyone knows him, as well as our boss, and we will answer questions as they come in or engage with other people. There's a lot of people, other developers on that are doing things on there just as you are, and they share ideas. They bounce ideas off of each other. There are multiple channels that you can do certain things in there. So again, you're more than welcome to join and talk to folks on there. There's a couple of channels. There's like Sqlcl and SQL Developer, ORDs, new products, customer stories, JSON development, stories that you want to tell of weird things that happened, as well as a features request channel as well. So you're more than welcome to get on there and talk to all of us. All right. Well, I think that pretty much ends it. I want to thank everyone for attending. I think this is going to be recorded, so thank you everyone who listened to the recording as well. And I think we could end.
CloudDB, shaping your new normal.